Hey guys, this is Coach Brian, and I am going to be going over our 2.1 through 2.3 quiz review. To start off with, we're going to be looking for remainders and determining if divisors are factors. So instead of doing long division or synthetic division, which you could do, we have this remainder theorem. And it states that if you take your divisor and you plug it into your function, if your answer is 0, then that means if you divided it all out, you would get a remainder of 0, and it is a factor. So the way this works is you take your number from here, you change the sign, and you plug it in to your function. Okay, see how I'm dividing f by x. So I'm going to go ahead and use function f, and everywhere there's an x, this is going to be my input. So I'm going to put in a -1, and it's going to be to the 5th power plus 1. Again, if you needed to, you could write this out, or -1 times -1 times -1 times -1. But the two things we need to focus on are that this is an odd number, a negative number, and this is an odd exponent. So we have a negative and an odd, which means you could go through this, 105 times, and the answer is going to stay negative, and since it's a 1, it's going to stay 1. So I end up with -1 plus 1, which is 0, and since my f of -1 is 0. That means if I divided this out, I'd have a remainder of 0, and yes, it is a factor. For the second one, we're going to do the exact same process. We're going to change our sign. We're going to plug it into function f. Everywhere there is an x, right there, we're going to put in a -2. And I like to put them in parentheses. I kind of overdo it probably, but helps me keep everything in order and keep my signs correct. So starting down the line here, we're going to have -2, okay? That's a negative input to an odd power. So my answer is going to stay negative, and then 2 cubed is 8. So that gives me -8. And then here I've got negative to an even power, which means it's going to become positive, and 2 squared is 4. So I've got -3 times 4. And then right here I've got 4 times -2, which is -8. And then I'm taking away 12. So my last little bit of simplification comes right here. -3 times +4 is -12. So what I end up with is -8 plus -12 plus -8 plus -12, and if you add all those together, you get -40. That means I would have a remainder of -40 if I divided this out, and since it has a non-zero remainder, it is not a factor. And you'll just continue this process for 3, 4, 5. We're going to actually divide. So again, I'm going to change the sign. I'm going to plug it into function f, so everywhere there is an x, there, I'm going to put in a 1. 2 times 1 to the 4th, plus 1 to the 3rd, plus 1, minus 4. So every time you have 1 raised, positive 1 raised to any power, it's just going to be 1. So all of these just turn into a bunch of 1s, and I've got 2 times 1, which is 2. And so I've got, when you write it out, 2 plus 1 is 3, plus 1 is 4, minus 4 is 0. And since I have a input a 1, I had an output of 0, that means I would have no remainder and that this would be a factor. Lastly, this one looks intimidating because of all of the gigantic exponents. But if I take a -1 and I put it into function f, everywhere there's an x, I'm going to input that -1. So, a lot of simplification to do here. Let's go chunk by chunk. We'll start on the easy end this time. 3 times -1 is -3. On this end, -1 squared is +1, and 2 times 1 is +2. Right here I have a negative to an even power, which means it's going to give me an even answer. So 3 times 1 gives me +3. Here I've got an odd, or excuse me, I keep saying odd, I'm sorry. I've got a negative to an odd power, which means it's going to stay negative, and 2 times -1 gives me -2. So as I look at my line of simplified chunks here, I've got a -2 plus 3, so that's 1, plus 2 is 3, minus 3 equals 0. Since there's no remainder, it is a factor. Now for number 5, it says to perform division. We are dividing x to the third plus 2x minus 8 by x plus 1. So the first thing you want to do here is you've got to account for all exponents. Okay, so we're missing a key exponent right here. We're missing an x squared. It's because there are none of them. There aren't any in our final answer, but as we're working these out, we need to account for them. So because this is a linear function with a coefficient of 1, we can use synthetic division. So let's go ahead and start with that just because it's a little quicker and faster, but I'm also going to show long division as well. So I've got x to the third plus 0x squared plus 2x minus 8. So I need to use those coefficients. I've got a 1, a 0, a 2, and a -8. And I'm dividing by x plus 1. So when I set that as a solution, it becomes -1. And then I'm sure you're familiar with the process. You drop the first coefficient, then you multiply these two together, and then you add. So 0 plus -1 is -1. -1 times -1 is +1. -1 times 3 is -3. And -8 plus -3 is -11. Sorry, I tried to make that look better and it got worse and worse. -11. So my answer is always going to have one, it's going to start at 1 degree less than my original dividend. So this was x to the third. It means my answer is going to be x to the second minus 1x plus 3. And then I've got this remainder, so I'm going to say minus 11 over my divisor, which is x plus 1. So that's my solution. And you know, if you're in one of my classes, I've been telling you long division works every time. So if you're not comfortable with synthetic or not sure if you can use it, you could always do long division, which would look like this. Go ahead and set up your division problem, dividing by x plus 1. Remember, you can take this first one and divide it by the first piece of the divisor. So x third over x gives me x squared. So the first thing I'm going to do is I'll put it in a different color so it's a little clearer. I'm going to put an x squared up here. I'm going to multiply that. It gives me x third. It gives me 1x squared. I put parentheses around it, and I'm going to subtract that. So these two should always cancel out. A positive minus a positive gives me a -1x squared. Bring down my 2x. I'm going to now divide by a negative x. Let me make all those in the same color. Negative x, because when I multiply that, it will make these match, which is what I want. And then I'm going to subtract. The first two should cancel out, which they do. 2 minus a negative. Minus a negative is adding. That gives me 3x. And then I bring down my 8. Excuse me, I got the sign wrong on that. Minus 8. And the last thing I'm going to add up top is a positive 3. That'll give me 3x plus 3. Put my parentheses and subtract. That gives me a cancellation. Oh, wait, actually, sorry, 1 second. 3 times 1 is not 1. 3 times 1 is 3. Subtract that, cancel. 8 minus 3 gives me negative 11. That's my remainder. So I've got a remainder up here of negative 11 over x plus 1. Sorry, not sure what just happened. All right, so if you want to check your work, you can always, work a problem twice and test it and try it out and see what you get. For number 6, we're going to be looking at writing polynomials based on their zeros and, any other given information. So for right now, that information is that the highest degree is to the 4th. So you would think there's going to be 4 terms. And if there aren't, we have to find a way to create, a situation where there's 4 terms. And we have different options. So the first thing we need to do is use this information of the zeros and what that actually means. We're saying x equals 2, x equals negative 3, and x equals 1. That's the solution form. So if you remember, where do solutions come from? They come from factors that have been set equal to 0. And so we can kind of reverse this process. Most of the time, it involves changing the sign. It can be a little more complex if there's a fraction or a square root or an exponent or anything like that. But we end up with these 3 factors. Okay, these are our factors. And we would write those out in a line like we were going to FOIL them. Now, the problem is, if I FOIL this and distribute it all out and do all those things to get to a polynomial, I'm only going to end up doing x times another x, which will give me x squared, times a third x, which will give me x cubed. And I need to get x to the 4th. So the way I get x to the 4th is I have to raise any one of these to the 2nd power. So option 1 is we could raise x minus 2 to the 2nd power. Option 2, I'm just going to write it below the line because I'm getting a little crowded up there. Option 2, we could raise the 2nd term to the 2nd power. And for the last, I could raise the final term to the 2nd power. And if you tested all of these out, you'd get 3 different answers, but they would all have these zeros, and we would know that for sure because we built them from these factors. And they would also have a degree 4 because of that exponent that we put into each of them. All right, factoring, everyone's favorite thing. Factoring, first thing on question number 7, I see 2 terms and I see a subtraction sign. So I should automatically be thinking difference of something, And, excuse me, I want to examine both of these and see squares, cubes, which one? Either one. But before I do any of that, GCF. So 64 and 27 can't be divided by 27, can't be divided by 9, can't be divided by 3, can't be divided by 8. I really don't think there's a GCF here, but I do notice that they are both perfect cubes. This is where it's really helpful to know those common squares and cubes. I know that 64 is a perfect cube, 27 is a perfect cube, and a cubed is a perfect cube. So what I need to do is I need to first find their cube root. So the cube root of 64 is 4. Okay, so I've got 4 cubed. Cube root of 27 is 3, and the cube root of a to the third, well look, third and third cancel, so that leaves me a cubed. All right, so what I've done is I've broken this down, and I've gotten my a and my b terms in these parentheses. The reason I want that is, you've got this formula, you will have it on your paper, but you've got this formula for both of these special cases of cubes, either sums or differences. And the way that you can make them easy to remember, although they're on your paper, is the acronym SOAP. Same, opposite, always positive. And so you should have this situation where, see how this is subtraction? I'm going to have the same sign. I'm going to have the opposite sign, and then my last sign is always positive. Same, opposite, always positive. So what I need to do here is everywhere there's an A, there, and there, I need to put in a 4. Okay? Everywhere there's a B, I need to put in a 3A. Don't forget your square at the end right there. Now I've got all my numbers plugged in. It's just a case of simplification. I can't do anything with these first parentheses, so I'm going to leave it as 4 minus 3A. Here I'm going to square my 4. That's 16. Here I'm going to multiply these together. That's 12A. And then I'm going to square this. So remember, I'm squaring the 3, which is going to give me 9, and I'm squaring the A, which is going to give me A squared. And that is my solution. It's a difference of cubes. This is the answer right here. For question number 8, I want to first check for a GCF. And there isn't one, so no GCF. The next thing I want to do is count how many terms there are. 1, 2, 3, 4. When there are 4 terms, you want to do what's called factoring by grouping. So I group the first 2, and I group the second 2, and then I see what the GCF of each of them is. So for this first one, the largest factor I can take from both of them is a y. And if I pull that y out by division, it leaves me with an x and a plus 3. Now on this side, the biggest GCF I can take from both of them is a negative 5. And when I take out a negative 5, it leaves me with x plus 3. And by now, you've probably realized that these should always match because you're going to factor them out. And then what's left is your next factor, y minus 5. That's your solution. Question number 9. I'm going to start by looking for a GCF. And there is one. I can take out a 3, but I can also, if I look at my smallest variable, an x squared, I can actually take an x squared from all of these. So I'm going to divide every term by 3x. I'm going to factor out, 3x squared. I'm going to factor out a pretty big chunk here. So I've got 3x squared out front. I've just factored it out, and what that leaves me with is an x squared plus 5x. And then right here, you can see I've got a negative sign, so you got to be sure to put the negative. These two cancel. 3 divided by 3 is 1. So I was able to factor out the 3x squared, and then I was left with a trinomial x squared plus 5x minus 1. Now, on this one, you could potentially further factor this guy. Once we take out the GCF, we can use the AC method. I might be going off a wrong track right here. On the key, it stops. So let's see if I can find some factors. Might not be factorable any further. 1 times 1 is negative 1. Numbers that give me positive 5. So this is not going to be further factorable for right now because the only numbers that can multiply to give me negative 1 are 1 and negative 1, and those don't add up to 5. So we would be finished at this stage right here. Looking at number 10, I noticed first that there are 2 terms, and I noticed that it's an addition problem, which means it's a sum. So the only special case that involves a sum could be a sum of cubes. And so I want to check and see, are either of these things cubes, which is pretty easy on this one because it's something to the third, and 8, which is a perfect cube. So what I want to do is I want to find their cube roots. So roots and powers cancel. These are going to cancel. And that's going to leave me a, b to the third, and I'm adding the cube root of 8, which is 2. 2 to the third is 8. So again, the reason I do this first is because it gives me my a. I know that's a little confusing because in this case it's a b, but it also gives me my 2, which is my b. And then I can remember SOAP. Same, opposite, always positive. Same, let me do this in a different color. Same, opposite, always positive. And then everywhere there's an A, I just put in AB. I know that's a little confusing. Everywhere there's a B, I put in a 2. So I'm going to write it down here where I have more room. AB replaces that A plus 2. And then I've got AB squared minus AB times 2 plus 2 squared. My last little stage here is going to be go term by term and see if there's anything I can simplify. In the parentheses, there's not anything I can simplify. Here, I can square both of these things. I can multiply these two together, and don't forget the subtraction sign, so 2ab. And then right here, I can square this, and it's positive, and it's going to be positive 4. There's my solution to the sum of cubes. Now, moving on, we've got a few problems left. 11, 12, and 13. question 11 says to solve by factoring, and the initial thing that I want to do in this case, just like every case, is look for a GCF. In this case, I can take out a 5. And when I take out a 5 from them both, okay, when I divide them both by 5, it leaves in the parentheses x squared minus 9. Now, taking out that GCF of 5 has created a difference of squares. There's two terms, it's subtraction, and they're both perfect squares. So anytime there's a difference of squares, the kind of solution, if you will, is if you get this situation where you have something squared minus something squared, your answer is going to be a plus b times a minus b. So in this case, what are a and b? Well, it's the square roots of these things. So I've got x squared, let me write that outside the parentheses, x squared minus square root of 9 is 3. So I've got x squared minus 3 squared. I've still got my 5 out front. That didn't disappear. And then in this case where I've got, a and b, this is my a, this is my b, so my answer is going to be x plus 3 times x minus 3. Still got my 5 out front. Now, the instructions here say to actually solve, okay? So if I'm solving, I need to take these two factors and set them equal to 0. 5 is not a solution. It's a factor, but it doesn't relate to a solution or an intercept. So you could take this one and go 5 equals 0, and you could be like, oh, wait, that's not true, so that's not an answer. And then here you're going to subtract 3, so we get x equals negative 3. That's one of our solutions. And then over here you'd add 3, so we'd get x equals positive 3. And that's our other solution. So those are our two solutions that we find by factoring and then setting the factors equal to 0. Now for this last one, there's no GCF and there's 3 terms, so we are going to use the AC method. I need to find two numbers that multiply to negative 12. Let me put an equal sign. They multiply to negative 12, and they add up to negative 1. So I was telling my classes that when you see this sum and it's 1 or negative 1, the numbers are going to be like their value, not necessarily their sign. Their value will be side by side. So what I mean by that is it could be like 9, 10 or 1, 2, 4, 5, something like that. So when I'm thinking about factors of negative 12, there's 12 and 1. Those values aren't side by side. 6 and 2, those aren't side by side. And then I come to 4 and 3. Okay, 4 and 3. Now, right now, both of these are negative, which means the signs are mixed up top. And then when they add up to a number, but they stay negative, it means my bigger looking number is negative. So the 4 here is negative, and you can check. Negative 4 times 3 is negative 12. That works. Negative 4 plus 3 is negative 1. That works. So these are my magic numbers, and that allows me to split this x value into 2 groups. Always a bell. All right. It allows us to split it into 2 groups and to factor by grouping. So I want to see what the GCF is of both of these. For this first one, I can take out an x. When I take out an x, that leaves me with x minus 4. And then on the second one, the biggest thing I can take out is a positive 3, and that leaves me with x minus 4. Remember, I want these two to match so that I can factor them out. So my factors are x minus 4 and x plus 3. Now, again, this asks us to solve, so I'm going to take x minus 4 and set it equal to 0. I'm going to take x plus 3, set it equal to 0, and that gives me x equals 4, and that gives me x equals negative 3. Those are my solutions. Last problem. What kind of division must be done on the expression? So if we go all the way up to question 5, we said if it's linear with a coefficient of 1, you can use synthetic. Let's go down and look at question 13. Question 13 is not linear. It is being divided by a quadratic. Okay, it's being divided by a quadratic. So we must use, where it says what type of division must be done, must use long division. Synthetic will not work in this situation. So the first thing we need to do is we need to write out our dividend. And we need to make sure that we're not missing any values along the way. See how I jump here from x squared to no x's? I need an x in there. So I'm going to put plus 0x minus 4. Then I'm going to put my little division symbol. And I am dividing by x squared plus 2. I want to see if I get a remainder or not. So the first thing that I am going to do is I'm going to take my first term here, 5x to the 4th, and divide it by my first term here. And that gives me 5x squared. So my first multiplier here is going to be 5x squared. So I'm going to distribute it to both of these, and that gives me 5x to the 4th plus 10x. Ooh, rewind. Look, I forgot to do something. While I did account for all of my x's here, I didn't account for them all here. So what I need to do, I need to rewrite this, and I need to include that missing x. That's why you have to do it. You see how I instantly ran into a problem? Instantly ran into a problem. All right, now we already said our first term is going to be a 5x squared. So I'm going to distribute it to all three things. It'll give me 5x to the 4th. It will give me 0x to the 3rd, because anything times 0 is 0. And it will give me 10x squared. I'm going to put parentheses around that, and this is how I do it. You can change the signs if you want. I like to just put a subtraction sign, and then I go positive minus a positive is 0. Positive minus a positive is 11. Positive minus a positive is negative 8x squared. Bring down my 0x, and then up top, I'm going to multiply by 11x. 11x times x squared is 11x cubed. 11 times 0 is 0. And 11 times 2 is positive 22x. Put that in parentheses. Subtract. 11 minus 11 is 0. Negative 8 minus nothing is negative 8. 0 minus 22 is negative 22. Bring down my negative 4. And my next part of my divisor is going to be negative 8. That will give me a negative 8x squared. It will give me another 0, and it will give me a minus 16. Put that in parentheses and subtract. Negative minus negative cancels out. Negative minus nothing gives me 22x. 4 minus negative 16 gives me positive 12. If you look, my biggest degree of my divisor is x squared, so I can't divide by anything else because I don't have any x squareds left. So what that means is this is my remainder. And so I've got my answer from up here, 5x squared plus 11x minus 8. And then I've got a negative remainder over the original divisor. And that's the answer. Hope this helps you get ready for your quiz. Make sure that you can factor, make sure that you can solve, make sure that you can divide. Good luck.